We use state design pattern in those scenarios where the behavior of the object, that is execution of its method, it changes as the internal state of the object changes. So internal state is nothing, it is simply the value of instance variables. So using state design pattern, we can avoid many if else statements and make our code easier, less complicated and easier to maintain. Let's take the example of a smart elevator system. The lift can be either going up, going down, or it can be idle. And in a smart elevator system, let's suppose an user is on 4th floor and they want to go to 8th floor. So they press the destination floor 8. Now there can be multiple lifts in that elevator system, and the elevator system will send this request to all the lifts to find the optimal list. And so each lift will have the method get time to reach floor, and once they return this time get time to reach floor, then the lift which can reach the fastest to floor 4 will be chosen. So a lift which is idle on first floor will take actually 4 minus 1, that is 3 seconds to reach floor 4, assuming that it takes a lift 1 second to move to next floor upward or in downward direction 1 second. Let's suppose a lift which is going down. So what will be the time taken to reach floor for that? It will be the sum of first that lift will go all the way down and process all the existing down request, and then it will start coming up. So the total time to reach floor 4 will be sum of both. A lift which is going up, let's suppose it is on floor 2. So time taken to reach floor 4 will be 4 minus 2, that is 2 seconds. And let's suppose it was on floor 6. Now that lift has already passed floor 4 and it is already going up. So it is an invalid lift for that request. So it will simply return an invalid value, like something like -1. Let's take a slightly different example of a cab booking system. So in a cab booking system, your ride can be in different states like ride requested, ongoing, ride finished, ride cancelled. And let's consider a common method like time taken to reach destination. If the ride is in cancelled state, then time taken to reach destination will return -1 because it is an invalid value or invalid state for that method. If the ride is already finished, then time taken to reach destination should be 0 because your customer or passenger has already reached their destination. If the ride is ongoing, then time taken to reach destination will be time taken to travel from user's current position till the destination position. And if the ride is already requested, only been requested, then it will be the sum of time taken for driver to arrive starting position plus time taken to go from starting position till destination position. Now there are two ways of doing this. First, either we put if else methods for each state and write the logic for each state in the same method, and the another one is using state design pattern. So let's see how it is implemented. For implementing a state design pattern, you need two things. The first one is either an interface or an abstract class, basically a super class, which contains all the common behavior, that is the common methods. So in this case, in case of a lift, I have used the class lift state. So it contains the common method like update floor, which will be called every second, or update direction and get direction, and the core method, which is get time to reach floor, which using which a lift tells the lift system how much time will it take to start processing a user's request, and using those timings the correct lift will be or optimal lift will be chosen for a given request. So the first part is your interface or a base class with common features, and the second part will be all the state classes which will implement those common features. For example, in the case of lift, we have moving up state, moving down state, or idle state. Now I could have just had a single class with these methods and used if and else statement for update floor. Let's suppose a lift is going moving up in up direction as is on 4th floor. So update floor called next second will update it from floor 4 to floor 5. If the lift was moving in down direction, then the floor would have become from floor 4 to floor 3. And if it was in idle state, then it would have remained at floor 4. So either I could have 3 if else statements, or I did it using a separate state. Same update direction, if a lift is moving up and it has reached the topmost position where it has fulfilled all the up request. Now if it has no request, then it will become idle, and if it has down request, then direction will change to D, that is down. Same goes for vice versa for moving down state. If a lift is coming down and it has processed all the down request, then if it has no other request, then it will become idle. If it has up request in its queue, then it will start moving up and the direction becomes U, that is up. Again, the get direction and the get time to reach floor, which we already discussed. So instead of using if else statements, we wrote the logic for different states in different classes. The benefit of using this approach is that if a new state comes, then we can simply have a separate class for it, and we do not need to disturb the code for all different states. So it becomes easier to maintain uh, in the long run. So coming to our question, design a elevator management system with multiple lifts. We do not need to actually solve this question. We just want to show you the how to use the state design pattern in this question. So elevator management system has a class lift. It has, every lift will have a current floor, then it will have a list of requests. Basically, in a smart elevator system, the user press the destination button or the destination floor, so the request will be known in advance, or they will be assigned in advance for a given lift. Then there are state variables: moving up, moving down, idle, and the state. This state variable keeps the current state of the lift. So lift is our client class which uses all the lift states. Then we already saw the common behavior or the common methods for the lift state, which is an abstract class. The methods are update floor, update direction, get direction, and the core method, which is get time to reach floor. And then we have the state classes which provide implementation for these methods: moving up state, moving down, and idle state. So starting with the idle state, as you can see, the logic for get direction returns I, then get time to reach floor has a separate logic, and we haven't implemented two methods, and their default implementation is enough for idle. Update floor and update direction does nothing since the state is idle. Then we have the moving down state, so it has its own logic for get time to reach floor. You do not need to understand this logic for now. Use it when you are attempting this question. And it has separate logic for actually updating floor and updating the direction, and get direction also returns D. So the logic for common methods is different here. Same, if you go for the moving up state, it has a separate logic for get time to reach floor depending on the floor and the direction, and the update floor and update direction and get direction also work differently. Get direction returns U in this case. Now what we could have done is we could have a separate class, but in that case the logic for all the get time to reach floor, all this code plus the get time to reach floor method in down direction moving down state plus the get time to reach floor in idle state, all this would have been a single method, and that would have been pretty complex. Also, if we were to add a new state, then we have to put more code inside that large method, so it would have been complex to maintain it. So using state design pattern was a better choice here, and all this pattern and common classes and state classes are used by our lift class. If you want to remember or take away just one thing about a state design pattern, then remember that whenever an object is changing its behavior, when its internal state is changing, that is whenever the execution of its methods is changing, whenever the value of its instance variables is changing, then we use state design pattern, and we are able to avoid too many if else statements. This was all about state design pattern. Now I have created a plan to prepare for low level design interviews. You can access it on codegym.com/roadmap. This is a 7-day plan. There are short videos on the most important topics and daily practice questions. So it will give you a decent level of preparation within 7 days. I created this plan because most of the time when interviews are scheduled, there is very less time. Either the interviews are on this week or in the next week. So most candidates are a bit confused because there is a lot of content on the internet and lots of YouTube videos. So they do not know which topics to read first or which YouTube videos to uh, uh, see and learn from, and which questions to practice most importantly. So time is of essence. So this plan has everything, basically easy to hard questions and most important questions first, most important videos or the videos on most important topics first. So give it a try, it will give you a decent level of preparation within 7 days. And thanks for watching the video. Wish you the best of luck. Bye.